Yeah, so we are going to write the program for this part. This is going to be a 2-operation lathe part. If you look at the print, the largest diameter is 4.36 and the overall length is 2 inches. So we're going to use 5-inch stock material that's 2¼ inches long. And we'll say that it's 17.4 stainless steel. Alright, so if you want to follow along, there'll be a link for the 3D model and the print dimensions in the description, okay? I'll probably put it in Google Drive or something on my website. But anyways, the model and the print dimensions will be available. Alright, so first thing I'm going to do is I'm going to go to Setup. And we're going to create a setup for our first op. I'm going to do this bigger side first. So now if you notice, the software already selected this in as my Z, right? So normally I would come over here and select Z axis and then click and actually select the face, but here we'll just do it. Alright, so I'm going to select this face. And now I put the Z on the wrong direction, so we're going to go flip Z, rotate it, and rotate the part too, or hit flip X. I like to do it with the X pointing up. Alright, so I'm going to go to the stock. I'm going to go fixed size cylinder. My diameter is going to be 5 inches, and my length is going to be 2.25. My model position is going to be offset from the front. And I'm going to offset it 100,000. So if you zoom into the part, the transparent part is the stock, right? So if you notice the distance from the origin, from the stock, that would be this offset amount. So if I change that to 1/4 inch, you can see the stock actually moves, right? So we're going to keep it 0.1. Program comment, this is going to be the name, so I'm going to name it Fusion 360 Cam Lathe Tutorial 2. Alright, so you see my setup here on the left. So what I'm going to do is I'm going to click in there and I'm going to change it to Op 1. I'll go ahead and hit save. Alright, so what we're going to do is we're going to do a facing operation, then we're going to rough the OD, finish the OD, do OD groove. We're going to drill it and bore the ID and then do the ID groove. Then we'll flip it over and we'll do op 2. Okay, so I'm going to do a face. Now, if you look at the toolpaths here, there's a turning face. Now, if you want to use a G72, what you want to do is you want to actually go to turning profile roughing. And I'm going to select the tool. I'm going to go here to add. I already have a tool created, but you know, I'll just do one so y'all know. So I'm going to go to turning general. This is going to be a CNMG 432. Insert, I'm going to do shape C, relief angle N, tolerance M, cross section is going to be G. We're going to do number 4, so it's a 1/2 inch insert size. Thickness is going to be 3/16, and radius 2. 32nd. Holder, I'm going to leave it as default. Cutting data. I see we got that Fusion 360 glitch. I don't know why mine's like that. It didn't used to be like that. I don't think it's to do this update because it's been like that for 3 weeks now. But let's see. Let's see stainless steel. Let's just go 350. Feet per revolution default 12 thousandths. Post processor, we'll make this to 1. I'm going to go down here on the bottom. I'm going to hit OK, and I'm going to hit select to select that tool. Alright, so I'm going to go to my geometry tab. On the front, where is it going to start taking passes? We're going to start taking passes on the front of the stock, right? So the front, we're going to go to stock front. On the back, we're going to go to model front. All right. So this is where we're going to start, and we're going to face all the way down to the face of the model. Radii. I usually keep these kind of basic. I would really suggest just keeping most of your stuff stock if you can. Clearance, I have stock OD. Outer radius, stock OD. Inner radius, stock ID. Okay, you want to get it where you don't have to input as much data as possible, because when you start creating toolpaths or writing multiple Lathe programs, so you can just knock out the programs. Anyways, so I'm not going to change anything there. That's, if you see the little 3 dots right here, you could change it as your user default. I would suggest that anything that you have to do repetitively, change it to your user default. It'll save you a lot more time. Cycle, so I'm going to go to vertical passes. I'm just going to face the Z0 and be done with it. But what you could do if you wanted to, you could have stock to leave and just leave 10,000, then come in and do a finish pass. In this case, we're just gonna face the Z0. But the key is cycle vertical passes. Make sure you get that, or you won't be facing. You'll be turning the OD of the face. But anyways, use can cycle. So when you have that, it's gonna put G72, and that's what you want. Linking tab. These are my presets. High feed rate. Preserve the high feed rate. Approach safe Z. Clearance. Approach X. Clearance. And you know, any kind of basic number here will work. What you want to do is you don't want to crash the tool into the part, and so you want to give yourself enough room, but you don't want too much room, because then you're cutting air, or you have a lot of air passes. Anyways, I'm gonna hit OK. Bruce, stop that. Stop that. Alright. Alright, so I'm gonna rename that toolpath face. I'm gonna hit save. Okay, so I'm gonna go to roughing OD. I'm gonna use the same tool to rough it, so I don't, if you notice, the tool's already there. It's already my default because I just used it. So I'm gonna go to geometry tab, model mode. We're gonna put it on front, back. What we're gonna do on the back right here is I'm gonna put it on selection. I'm gonna zoom in to this edge right here, and I'm gonna go additional 50,000, so minus 0.05. Radii, like I said on these roughing toolpaths, just keep it stock if you can. I mean, sometimes you're gonna have to change it, but you know, it will cut, the tool will cut down to the bottom. So distance, stock OD, additional 200,000, so that's for clearance. Outer radius, stock OD, so it's gonna start cutting the stock diameter. Inner radius, put it on stock ID, and it'll stop at the bottom. Cycle, we're having a horizontal direction, front to back. Grooving, don't allow grooving. If you allow grooving, it's going to try to come in here and actually cut that groove. You don't really want that. We're going to use a groove tool for that. But anyways, maximum depth of cut, we're putting out 100 thousandths, and stock to leave. We'll save 10 thousandths on the X and 2 thousandths on the Z. Linking, you can use anything that's reasonable on here is fine. Your Z clearance 50 thousandths, X clearance 10 thousandths, retract 50 thousandths. So I'm gonna hit OK. This is what it looks like. I'm gonna rename this toolpath OD rough. We need a finish tool. So I'm going to go over here to turning profile finishing. I'm going to select the tool. We're going to create a tool. So we're going to go turning general. And this is going to be a VNMG 332. So our shape is going to be V. Our relief angle N. Tolerance is going to be M. Our cross section type is going to be G. Insert size 3/8, so 3. Thickness is going to be 3, which is 3/16. Corner radii number 2, which is 1/32. Holder, I'm going to leave this default, so we don't even have to change anything. And oops, our surface footage is going to be 350. It does not like that. Tool number, we'll do tool number 2. Oh, jeez. Alright, so I'm going to hit OK. And I'm going to hit select to select that tool. Alright, so now I'm going to go to the geometry tab. Front is going to be model front. Your back, we're going to put it on selection one more time. And we're going to zoom in. We're going to select the edge of that shoulder. And we're going to go additional 50 thousandths back, so minus 0.05. It's going to look something like that. Radii, same thing as we did on the OD roughing. We're going to leave that default. Passes tab, direction, front to back. Grooving, don't allow grooving because the tool's going to try to come in and cut that undercut. Step over, I mean, we're finishing, so it doesn't really matter what you have there. I really wouldn't worry about it. Anything that's, see, we save 10 thousandths per side on the X, so anything that's larger than 10 thousandths is going to cut the material, as long as you don't have stock to leave on, so make sure that's turned off. Linking, the safe distance 0.1. Bruce, stop that. Stop it. Safe distance 0.1. Approach Z. Bruce, stop. Safe Z. Approach X. Clearance. Let's see. Lead-in radius. I don't like to have a lead-in radius. All right. I just like a simple tool path. Linear lead-in. Do 50 thousandths. And I'm gonna do it at a 45-degree angle, and it's gonna be 45 degrees relative to this 45-degree chamfer that's on the end, right? So if you look, my lead-in is actually straight in, and I did it on purpose. That's the way I like to do it. Works out good for me. Alright, so I'm gonna hit save. Alright, so the next thing we're gonna do is we're gonna do the OD groove. So I'm gonna go to turning, groove roughing. We're gonna have a roughing groove and a finish groove. Alright, so what I'm gonna do is I'm gonna select a tool. I'm gonna go to this plus sign right here. I'm gonna add a turning grooving tool. And we'll call this 156 wide OD groove R 0.0223. Actually, you know what, hold up. Yeah. So R 0.0078. It's I think it's a 0.2 millimeter radius. Let's see, what was that? 0.2. Yeah, 0.2 millimeter. Bruce, stop it. Stop. Okay, so turning grooving, we're going to keep all of this same. At default thickness. I don't know how thick it is. We'll say a 1/4 inch. I'm going to be honest, thickness doesn't really matter too much. Overall length, that will affect you if your groove tool isn't long enough to go a certain depth. In this case, our groove is kind of shallow, so anything that's a reasonable length will work. Now the thing is, really what you want to do, to get this right and set up your tool libraries, actually go measure the tools, look them up online, each insert, get the correct specs. Then you won't have any surprises. Overall length, I don't know. Let's do 625. Now here's what's actually going to affect the G code, the width. Make sure you get this right. 156, and the groove width is 0.156. I just put these numbers the same. It really is this groove width you need to look out for. But I like to put these numbers the same. Corner radius, we're going to do 0.0078. You can round that up if you want to. Holder, most of this will work by default unless you're doing something where you actually need clearance or reach. We are doing a simple groove, so surface speed, let's just go 250. Kind of slow, but we'll go 2000ths feed rate. Tool number 3. So I'm going to hit OK, and I'm going to select that tool. So now we're going to go to the Geometry tab. And what I like to do on V-roughing, I don't actually include the chamfer. The reason why is Fusion 360, the post processors are really bad about making the groove toolpath, the actual G code, a lot of code. It comes in, it does all kinds of movements and compensations. It's all over the place. So what you want to do is you want to simplify your groove as much as possible to shorten the length of the code. So what I do on V-roughing, I'll select just this edge for my front. The back, I'm going to put it on selection, and I'm going to select this edge. So I'm not selecting the chamfers. I'll do that on the finish. It's a small chamfer. It's only a 10,000th chamfer. Now, if you have a really big chamfer, yeah, add that into the roughing. In this case, none. So I'm going to go radii, clearance, stock OD. Actually, you know what? Let's do this. Clearance, I like to select this and add 25 thousandths. I like to hover that groove tool over the OD and just come down in position. The reason why is Fusion 360 will it'll start the toolpath up too high, and then it kind of feeds down. I don't know. If you're going 2000s feed rate and you're pecking, that will take forever. So you want to keep this distance as short as possible, as closest to the diameter, the actual diameter of the part. So let's say 25 thousandths. Outer radius, I'm going to put it on selection. I'm going to select this OD, offset. We'll keep that at 0. Inner radius, I'm going to put it on selection, and I'm going to select the ID, or the diameter, the outside diameter. Anyways, passes, you get different ways you can do this. I like to do side. Keeps it more, however you like to do it, keep it consistent. Order depth. I'm going to go depth first, then width. This matters if you're pecking. If you're not pecking, it doesn't really matter. Direction from front to back. Tolerance, I'm not going to worry about that right now. Your maximum step over. So I would go 80% the width of the groove insert. So it really just round up. It doesn't have to be perfect. See, 0.156 times 0.8 is 120. It's about an 1/8 inch. So my maximum step over is 0.125. Pecking depth, I'm going to peck every 50 thousandths, and I'm going to retract 10. Okay, if you retract too high, it makes your cycle time longer than it should be, and if you're pecking too little, it makes your program really long. It also makes your cycle time long too. Stock to leave, I'm going to leave 2 thousandths on the X and 2 thousandths on the Z. Linking, Anything that's reasonable will be in here. Will be good in here. Preserve rapid feed rate. Approach. We'll do safe Z. Retract Z. Safe Z. Approach X. We'll do clearance. Approach X or retract X. We'll do clearance. Stock clearance 20 thousandths. Relief. We'll leave it at 40. See what it does. All right, so let's right click and simulate this. I would definitely suggest simulating your groove tool before you get too far along. So I'm gonna single block it. That looks good. If you notice, it didn't add the chamfer right there. That's what we want. All right, so I'm gonna name this toolpath OD Groove Rough. I'm gonna hit save. All right, so now we're gonna do a finish, right? What I like to do, I think it makes it way simpler. I take that. Actually, we're not gonna do that. I was gonna say duplicate it. You could duplicate it, but because this is a tutorial, we'll we'll do it the long way. Anyway, so I'm gonna go to turning groove finishing. I'm going to select the same tool, so I actually don't have to select the tool because I'm using the same groove tool. If you're using a different one, yeah, create that tool. Speeds and feeds are the same. Front. So I'm going to put it on selection. I'm going to select the front of this chamfer, where the chamfer starts. And I'm going to put it on back, selection. And I'm going to select where this chamfer starts. I'm going to go radii tab. I'm going to put it on selection. And I'm going to hover that tool 25 thousandths above the stock, then feed it. Outer radius, I'm going to select this diameter. I'm going to leave my offset at 0. Inner radius, I probably, since I'm putting on selection, I'll just select this. You probably could do stock ID. Here, let's see what it does. I think it'll work. Let's see, stock ID. Yeah, it still works. What I usually do is I put it on selection and actually select it. The reason why I do that is I have all 3 in selection. I don't know. It's just, it doesn't matter. It's kind of a tomato kind of situation. Okay, so on the passes tab, I'm going to put it on front to back. And I like to select this avoid upward cutting. Okay. Now you're gonna need an overlap. 40 thousandths works good for overlap. Something that's probably something that's more than your radius that's on your groove insert. And I'll show you what I'm talking about. So I'm gonna hit OK. I have stock to leave, and we're not saving stock. This is a finished toolpath. Same basic linking settings. Preserve rapid movement, safe distance, 0.1, safe Z, your approach X and retract X, put it on clearance. Lead-in radius, I put that at 0. I don't like the lead-in radius. Linear lead-in length, 50 thousandths, work. 45 degrees, yeah, let's try that. Alright, so we're going to simulate it. So I'm going to right click on the toolpath, go to simulate, and we're going to single step it. Looks good. Comes over, comes back down, and then it overlaps a little bit and comes out. Now you could just drop that tool in and feed over and feed out if you if you want to. I'll show you what I'm talking about. So if I right click here, go to edit on the passes tab, instead of avoiding upward cutting movement, if I uncheck that, what it'll do is the tool's going to come in, feed down, feed over. Then it's done. I think it cuts a lot better feeding into the part. It's just the way the tool's designed. So I'm going to hit OK. We're going to rename that toolpath OD groove finish. Okay, so next thing we're going to do is we're going to drill a hole. If you look at the print, the smallest diameter is 2.75. So we're going to drill with a 2.5 inch drill. So I'm going to go to drilling. I already have a drill, but let's make another one. So I'm going to click this plus sign. And I'm going to go to drill. I'm going to 2.5 inch. Insert a drill. Cutter. Diameter is going to be 2.5 inch. I'm going to jump down to the angle. We're going to do 180 degrees tip angle. The rest of it we're going to leave default. Let's jump over to the cutting data. Surface footage, let's go 275 for stainless. Sounds good. Feed rate, let's use vertical. Use feed per revolution. And let's do our plunge feed rate 0.00. We'll say 2.5 thousandths per revolution. Post processor, tool 8 will be fine. Just hit select. Geometry tab, I'm going to select on this hole right here. Height tab, my clearance height is going to be model top plus 2 inches on the offset. Retract height is going to be model top plus 100 thousandths on the offset. My feed height is going to be model top 100 thousandths offset. My top height is going to be model top 0. And my bottom height is going to be, let's put it on stock bottom because we want the drill to drill all the way through the stock. And we'll do an offset of -0.05 to make sure that drill actually goes all the way through. Cycle type, we'll put it on drilling and linking. Don't worry about that. We'll hit OK. And here's our drill. Looks good. You can simulate if you want it, but it's a regular drill, so it should be fine. If you're not familiar with this, really, if you're new to Fusion 360 or creating toolpaths, I would simulate everything. I mean, I simulate anyways. Trying to keep this video short, so I already know what the drill looks like, so I'm not going to simulate it, but I would suggest that you simulate every toolpath that you do, at least getting started. So I'm going to name this toolpath 2.5 inserted drill. Alright, so we're going to be doing internal work, so let's get a cross-section view right there. And remember, anytime you're doing internal work on a lathe part, it's a lot easier to view it if you can see the cross section, or you can see the inside of the ID there. So remember, just go to section analyst and do a section view, 180 degrees. Alright. So now we're going to bore this. So I'm going to go to turning profile roughing. I'm going to select the tool. I'm going to get a plus sign. I'm going to add a tool. I already have a boring bar, but let's add another one. Now, it's better to do this when you have the boring bar in front of you, where you can actually measure everything and write the right dimensions. But I'm going to kind of guesstimate on this. So description, let's say it's going to be a VCMT 221. Boring bar R.016. Insert, so my shape is going to be a V, my relief angle is going to be C, tolerance M, cross section T. So VCMT 2, so it's a 1/4 inch insert size, that's the inscribed circle. Thickness is going to be 2. Corner radius is going to be 1/64. setup, we don't have to worry about that. We're going to use our default surface footage. Let's go 350. I'll go 8,000 feeder rate because it's a tiny bar. Actually, on the holder, it's not too bad. That'll work. It's a little big, but really, you want to measure your actual boring bar size, or look it up if you get the part number. All right. So I'm going to jump to the geometry tab, and what I'm going to do, front is going to be model front. Back, we'll go ahead. Let's go ahead and bore it through V stock. So I'm going to say stock back. Okay. And we'll go additional 50 thousandths. Radii. Here, let's just try it at this. Let's see what this looks like. Actually, it doesn't look bad, but okay. So sometimes, one thing about Fusion, sometimes if you're not sure what you're gonna put, just hit OK and see the toolpath it gives you, and kind of go from there. Because sometimes people put a little bit too much information, or it's not necessary. You know, Fusion will have, a lot of times Fusion won't have enough information to generate a ideal toolpath, or at least a functioning one. You can kind of see what you don't like, and you know what to change once you get familiar with, you know, the settings and toolpaths. Okay, so like I said, I just did that, and it gave me a toolpath. It's not really what I want. It's because it starts boring from the center. And let me show you what you change. So I'm going to go to my radii, and let's do this. It says stock ID. Let's put it on selection. I'm going to select this diameter. My clearance. Let's put it, you know what? There it is. My clearance, now I drilled with a 2.5 inch. So let's just make that 2.4. See what that looks like. Alright, didn't like that. Okay. Minus 0.1. Let's put our clearance on selection. Okay, so one thing on the passes tab right here, I'm going to change the depth of cut to 50 thousandths. My stock to leave is going to be 10 thousandths on the X and 2 thousandths on the Z. And let's see what this looks like. Okay, so one thing, notice the boring bar isn't going all the way through, so we need to change. So I'm going to go to edit, and my back, I said stock back, I meant to say minus 50 thousandths, and it got it there. So we have a warning. Let's check out the warning. X clearance trimmed at clearance radius. All right, so let's see what we can fix that. There we go. So I increase that that distance so it comes down further. Let's go ahead and name this ID rough. Now, when we do the finish, we're going to use something similar on the radii. Notice on the outer radius, I have stock OD. Now, it knows, the software is smart enough to know if I'm doing an internal feature, because I'm using the Bourne bar, and it's going off the model. So it's as long as I don't have grooving activated, it's gonna stay on this this diameter right here, the 2.75 diameter. Let's go ahead and save. Okay, so let's finish this now. So I'm gonna go to turning, profile, finishing. We're gonna keep the same speeds and feeds. Geometry tab. Put model front to back. Let's let's put stock back. And we'll go additional minus 0.050 thousandths. Outer radius is going to be stock OD, offset 0. Inner radius is going to be, let's just put it on selection. We're going to select that diameter. Let's go minus 0.1 offset. Clearance, we'll select this diameter. Let's try 100,000. We'll see what it says. That's good right there. Now notice I didn't change anything else. The passes tab, the default what I have right here is good. Step over, this is a finished pass, so you don't really have to worry about that. We're just taking one pass. Direction, front to back, that's default. Grooving is don't allow grooving. That should be default. If it's not, I would make it default because it'll save you time and trouble. Save as user default. Basically anything that you change a lot, or any kind of preference, make sure you save it as a default. Stock to leave, none. Linking tab, this is the settings I have. Preserve rapid movement, safe distance 100 thousandths, approach and retract, safe Z, approach X and retract X, clearance. My linear lead-in, I have 100 thousandths, and my linear lead-in angle, 45 degrees. Now if you notice, it's straight in there. That's because it's 45 degrees relative to that 45 degree chamfer, so that's why it's straight in. So I'm going to name this ID finish. Alright, save. Alright, so the next thing we're going to do is we are going to do the toolpath for roughing and finishing the ID groove. So I'm going to go to turning groove roughing, and we'll go ahead and create a tool. I already have a tool, but we're going to make one so y'all can see the process. I'm going to go down to turning grooving. We're going to call this 0.156 wide ID groove. R 0.078. Thickness. Overall length, let's see, thickness, we'll do 7/32. Overall length, we'll do 0.65. Width, 0.156. Radius right here, 0.0078. Head length, and groove width, 156. Alright, so the main things that y'all really need to get right, well, the insert's got to be long enough to reach, and it can't be too long because sometimes you need clearance. But really the main thing is the width, right here, groove width, 0.156. always make the width and the groove width the same. It just helps me know for sure I got that width right. But anyways, the main two things is groove width and the corner radius if you're going to be putting chamfers on. If you're just doing a straight groove, corner radius isn't that important. But if you're going to be putting chamfers on, or you need to have a radius in the floor of the groove, it's going to be very important. All right, so I'm going to go to holder, style. I'm going to go to internal grooving. It's going to be right-handed. Cutting width. Let's go 0.625. Head length 1.5. Overall length 6 inches. Shank width 0.75 inch. Now, really, it helps to have the tool with you and actually take the real measurements. In this case, I'm kind of winging it. I know what's important and what's not. So I can, the main thing is I need to have clearance and room to get the tool in there without it gouging the stock or the workpiece. And I need to make sure the width and the radius of the insert is right. So the geometry and the G code is actually the proper code. Setup. We're going to leave this how it comes default. Cutting data. We'll go here. Oops. We'll go 275. We'll go 2000 feed rate. Post processor, tool 5. We'll go ahead and stick with that. Alright, so I'm going to hit select. I'm going to go to geometry tab. So my groove, I'm going to put it on selection, and I'm going to select the groove, not including the chamfer. Okay, on roughing, we are not going to worry about the chamfer. We want to keep the G code simple and short as possible. That's only a 10 thousandths chamfer, so the finish tool can get that. Okay, so front, I select the front of the groove. I go to back, I'm going to put it on selection, and I'm going to select the edge right here. We're going to go ahead and jump to the radii tab. Outer radius, I'm going to put on selection. I'm going to select the floor of the groove. Inner radius, I'm going to select the ID of the part without the groove. And clearance, I'm going to select the ID. And I'm going to go minus 0.025 inch. It's 25 thousandths. Passes, my tool entry is going to be side. My order is going to be depth first. My direction is going to be front to back. Tolerance, let's do 4 thousandths. Maximum step over, 0.125. That's roughly 80% of the width of the insert groove. I'm going to use pecking, and pecking depth is going to be 50 thousandths of an inch. Pecking retract, 10 thousandths. So I just want to slightly come up, break that shaving, and come back in. Cusp cleanup, I'm going to do semi-finish pass. And stock to leave, 2 thousandths on the X and 2 thousandths on the Z. We'll go ahead and leave our linking tab how it is by default. Alright, I'm going to name this toolpath ID groove rough. Let's go ahead and simulate it. And there's an error. It could be the tool. We'll check it out in a second. Actually, hold up. First, let's check the profile of the tool. So I'm gonna single step this in there. Looks good. Semi-finish. All right. You zoom in, you can see we saved 2 thousandths. I'm gonna rewind it some, and oh wow, why does it look like that? Huh. Interesting. Didn't look like that a minute ago. Let's check our tool there. Okay, that Now, if you notice, the tool actually looks good right here, the geometry. That's going to be the actual geometry that Fusion 360 is going to be going off of. The simulator looks kind of funny. I think that has to do something with my my video card, because I am using Fusion 360 and I'm recording the screen at the same time on a laptop, and I think the simulation is looking kind of weird. But anyways, so that's the ID Groove Rough. That shouldn't cause any problems. The G code, what's going to matter is the G code is going to be correct. Okay, so the next thing we're going to do is we are going to do the finish for the ID Groove. So I'm going to come over to ID Groove, or Turning Groove Finish. We're going to use the same tool, so the tool's already there. I'm going to go to the Geometry tab. On the front, I'm going to go to Selection. I'm going to select where the chamfer starts right there. I'm going to go to Back. I'm going to go to Selection, and I'm going to select where the chamfer ends. If you don't select the chamfer won't be on there. Alright, so I'm going to go to the Radii tab. My outer radius, I'm going to put on Selection, select the floor of the groove. Inner radius, I'm going to put it on Selection. I'm going to select the ID about the groove. Offset, we're going to leave 0. I'm going to go to Clearance. I'm going to go to Selection. I'm going to select the ID again. This time I'm going to do an offset of minus 0.025, 25,000. Passes, direction is going to be front to back. Overlap, 40 thousandths. And I'm going to check this avoid upward cutting, okay? And what that's going to do is the tool is going to come in, it's going to cut one side, move over to the middle, then it's going to jump back out, come over to the next side, and cut down. So it's going to cut downward here. I'll show you all. Step over, we're just finishing, so that doesn't really matter. And make sure you don't have stock to leave checked. Alright, so we'll get it okay. So right now I have avoid upward cutting selected, and this is what it's going to look like. So I'm going to go simulate. Alright, so right here, so we're going to go, tool comes back, it's going to feed in, go across. Now notice it's not touching that wall right there. It's going to come out, then reposition itself and feed downward. Get the rest of the material, then come out and out of the part. Alright, so if we were to change it to the avoid upward cutting unchecked, what you would see is something like this. Alright, so the tool comes in, and notice we have the error. We'll fix that error in a second. Alright, so the tool's going to come in, it's going to get in position, feed in, over, feed back, hit the back wall right there, and finish it like that. So basically, instead of cutting down each pass, it's cutting down in the front, and it gets to the back, and it cuts outward. Alright, so let's check out this error right here. Lead in has been modified due to gouge or model in process. Okay, lead in, so is that what your lead in? Just lower that. Alright, all good. So I decreased the lead in from 80 thousandths to 40 thousandths, and the warning went away. So we are good. Okay, so now we're going to start the second op, and what I like to do, since we already have a bunch of toolpaths set up to go for this part, what I'm going to do is I'm going to click on the op 1 and I'm going to duplicate it. Alright, so I'm going to rename it op 2. I like to clean up these names here. You don't really have to do it. It's kind of just aesthetics, but it's what I do. Okay, so we'll go ahead and flip Z. So the flip Z is already checked, so I'm going to uncheck it. So the Z is coming from the other side of the part. It's going to look something like this. Then I'm going to go to stock, and I'm going to change it from fixed size cylinder to from preceding setup. I'm going to check the continue rest machining, and we're going to hit OK. And if you'll notice, the stock is updated from what's already been machined. You might be hard to tell, but it's kind of translucent. But anyways, just compare the transparent, the semi-transparent stock to the darker yellow right there. All right. Anyways, I'm gonna right-click on Op2, and I'm gonna regenerate it. And we'll go ahead and check these toolpaths out. So I'm going to go to face, make sure that looks good. That looks alright. OD rough, I'm going to right click on it. And I'm going to change this in position. I'm going to keep it on selection, but I'm going to select where this chamfer ends right here. And I'm also going to type in a tangential extension. If you don't do that, what will happen, it's really more pronounced on finishing passes. But what will happen is the tool will not quite go back far enough, and you'll get a burr. Alright, so I'm going to go to the radii tab. We're going to keep this the same. Everything's going to be the same, so I'm going to just hit OK. Looks good. I'm going to go to the finish pass, and I'm going to hit edit. Actually, you know what? Let's skip the finish pass. What we're going to do, we're going to add in a second roughing pass and then cut this thread relief right here. Right. So what I'm going to do is I'm going to right click on OD rough, and I'm going to duplicate it, and I'm going to rename the duplication thread relief. Now this is going to rough the thread relief, and then what we'll do is on the finish we'll change it to undercutting, so it'll finish that whole profile. Anyways, so thread relief, I'm going to edit, we're going to go to tool, and we are going to select our VNMG 332. And select. Our surface footage is going to be 350. Our geometry tab, we're going to go to selection, and I'm going to select where that thread relief begins, and on the back I'm going to go to selection, and I'm going to select this wall right here. Alright, so then I'm going to go to radii. We're going to go to selection. I'm going to select this OD. I'll do extra 50,000. Actually, let's do 25. Outer radius, I'm going to put it on selection. I'm going to select this diameter again. Inner radius, I'm going to put it on selection, and I'm going to select the floor of that thread relief. Then I'm going to go to passes. We're going to keep it on a horizontal. Direction front to back. Grooving, we're going to put it on allow radial and axial grooving. Our depth of cut, we can't go 100 thousandths. We're going to change this to 35. You want to keep it kind of shallow because the way the tool is going to feed in, it will break your insert. Stock to leave, we're going to leave the same amount of stock, 10 thousandths on the X, 2 thousandths on the Z, and we'll go ahead and hit OK. So it's going to look something like this. If I right click, I'm going to go to simulate, and it's going to come in, comes back to this wall, shoulder, comes in, takes another pass, and make sure you save material to finish right there. You don't want that could, if you don't, that might be, it might that distance may not be in specs of the print. Alright, looks good. So on the OD finish, now we're going to go to edit. Geometry, the front is going to be the model front. The back, I'm going to put on selection. I'm going to select where this chamfer ends. I'm going to clear out the offset that was in there from the previous operation. Tangible extension, we're going to put 10 thousandths. I'm going to go to radii, and and we'll leave it at clearance, stock OD, offset 0.2 is fine. Outer radius, stock OD, offset 0. Inner radius, stock ID. Passes. The main thing you really want to change is where it's going to be finishing, and you want to change it to allow radial and axial grooving. So I'm going to do OK. And let's go ahead and simulate this. I'm going to right click. I'm going to go to simulate. And the tool comes in, comes down, comes up, and it gets that chamfer, and it gets out of the way. Looks good. Let's go ahead and hit save. OD groove. We'll delete that out. We don't need that. Okay. ID rough. So what I'm going to do, so I'm going to go to edit. Now we already cut the material up to this chamfer right here. So all we have to do, we're going to keep the same tool. Our front on the geometry tab, our front is going to be a model front. Our back, I'm going to put it on selection. I'm going to select where we left off, clear out the offset to 0, and we'll add a tangential extension of 0.01. Radii. We're going to keep it the same. Go to passes. Everything else stayed the same. The same duplication, because remember we got this, we duplicated the first op, and so this is the ID rough, so a lot of this is already set for us. Alright, so it's going to look something like that. Now I'm going to go to the ID finish. I'm going to go to edit, and all of this is going to stay the same on the tool tab. Geometry tab, the only thing we're going to change is I'm going to go to back, put it on selection. I'm going to select where the tool path left off from the first op. I'm going to clear out this offset, change my tangential extension to 0.01. I'm going to go radii. We're going to leave this where we're at, where we left off. So from the first op. Everything else should be good. Let's hit OK. Okay, so next thing we're going to do is we are going to thread the OD. So I'm going to go to turning thread. I'm going to select that threading tool. I have a OD thread Acme 4 pitch right here. Spindle speed, let's go to 75. I'm going to go to the geometry tab, and definition, manually select the thread face right here. Okay. Thread pitch, it's going to be 1/4 inch. my thread depth. So I got the gauge maker sheet right here. So my pitch is going to be a 1/4 inch. It's a 4" 4 Acme, right? So it's a 4 pitch. So 1 inch divided by 4 is 0.25. So my thread pitch is going to be 0.25. Thread depth. Now looking at the gauge maker, I have 0.135 thread height. Okay, so thread depth is the same thing as thread height. I like to add an extra few thousandths onto it because it helps. It helps you reach your minor diameter. Don't ask me why. I don't understand I haven't actually looked into the math that they use to calculate it, but the G code comes out correct. So thread depth, I'm gonna go 0.138. Front. So I'm gonna start a 1/4 inch in front of it. So the thread pitch is a 1/4 inch, so I'm gonna have a thread lead of a 1/4 inch. Back, I'm gonna put it on selection, and I'm gonna select this wall right here, but I'm gonna offset it 25 thousandths. And I just do that as a quick and easy way to make sure you go far enough on your thread. You don't want to go too far, but you don't want to go far enough. So I take it all the way to the wall and then add 50 thousandths away. Or 25, I'm sorry, add 25 thousandths clears. Alright, so I'm going to go to radii tab. Make this 0.1. Okay, passes tab. We're going to use can cycle. It's going to output a G92. And what we're going to do is we said our thread height for our depth was 0.138, right? So I want to take, say I want to take 4 thousandths passes, right? 4 thousandths per pass. That's per side each pass. So I'm going to take 0.138 divide by 0.004, and we get 34.5. So let's put 34 here. How about this? I want to have a nice clean number. It's got 4 thousandths and 1/10. Not really bad, but so that's 34.5. What I'm gonna do, so I'm gonna go back to geometry tab. I'm gonna put this at 0.14. Is that right? And now I go back to the passes tab right here. Put this at 35. So basically, here, let me show you the math. So originally I had 0.138 for my thread height. I wanted to take 4 thousandths depth of cut per side. So I divided 0.138 divided by 0.004. It gave me a 34.5. So you can't have half a depth. Okay, it's got to be a whole number. So what I did was I changed it to 35, rounded up. 35 times 0.004, I got 140. So then on our geometry tab, I changed my thread depth to 0.14. Now the main thing is the minor goes in the correct spot. Okay, that's the main thing, and this way it will. We'll check it. Anyways, let's go to passes. So we're good there. You can add a spring pass if you want. I'm gonna hit OK. Alright guys, so this is the part. You got your first op and your second op. Got your thread. Everything looks good. Now the real test is to post it and make sure the G code is correct. And we'll do that the next video.